Okay, so today we're talking about the last topic with polynomials, conjugate pairs, and zeros. So like I've said, I've mentioned that a polynomial, okay, quadratic cubic function, can have imaginary complex roots, right? If I have a parabola that never touches the x-axis, it has roots. They're just complex numbers, right? And maybe, a plus or minus bi. When we have an imaginary root, it automatically gives us 2. Okay, so right, so we have the rule. If f is a polynomial with real coefficients, and a plus bi is a solution to the function, then its conjugate, a minus bi, is also a solution. Okay, so one way that this comes into play is when we have a quadratic and we use the quadratic formula to solve. The complex conjugate is already built in. We have negative b plus or minus the square root of blah 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 blah. So when we get a negative number underneath that radical, and the plus and minus in the formula already, that gives us our complex conjugate, right? So you have 2 plus the square root of negative 5 over 3, and then 2 minus the square root of negative 5 over 3, right? Those are automatically complex conjugates. Given something like this, you could use polynomial division and get your way down to a quadratic where you have to use the quadratic solution. Or they might give you one of the solutions and then tell you to move on from there. So that's what we're going to look at today. So here we have a polynomial function, and they tell you one of the solutions is imaginary. All right, so what do we do with that? So I have an x we know is 1 plus 3i. So that's its solution. So as a factor, okay, remember we can switch between factors and solutions. A solution is 1 plus 3i. So a factor is x minus 1 plus 3i. Because one of my solutions is imaginary, I can automatically say that its conjugate is also solution. The reason this works out so well, and we've seen this before when we were simplifying fractions, is when we multiply complex conjugates, the imaginary part disappears. All right? So what we do is we multiply these two together. Now what I'm going to do is I'm going to distribute this negative to both. All right, so I have x minus 1 minus 3i. I distributed that negative to both of those. I have x minus 1 plus 3i. So now this part is probably one of the longer parts. You just have to, distribute everything. So we have x times x is x squared. X times negative 1 is negative x. X times 3i is 3ix. We move on to the negative 1. Negative 1 times x is another negative x. Now I'm going to do it like this. I'm going to put my new multiplication down here. Negative 1 times I is positive I. Negative 1, I'm sorry, that's a 1. Negative 1 times negative 1 is positive 1. Negative 1 times 3i is negative 3i. And now we do the negative 3. Negative 3i times x is negative 3ix. And look at that. They're opposite signs. So when we simplify, that's going to work out nicely. Negative 3i times negative 1 is positive 3i. Negative 3i times positive 3i is negative 9i squared. Okay. So this part here may look a little different to you. I like to do this when I distribute more than just the normal FOIL. It helps you kind of organize things, so you don't have just one long list of terms and then you have to combine like terms and things like that. Here I already have it lined up where we just have to add everything together. So adding down, I only have 1x squared, so that's going to be x squared. I have a negative x plus negative x, so that's minus 2x. Those are gone. That plus 1 is by itself, so that's plus 1. Those are gone. Now this negative 9i squared, remember I squared changes the sign, so that becomes plus 9. So when I multiply these two polynomials together, I get x squared minus 2x plus 10. Now, if I try to go backwards, and if I try to factor this, there's no two numbers that multiply to 10 that'll add up to 2, right? 1 and 10, well, that'll give me 9 or 11. And 2 and 5, that'll get me 3 or 7, right? So this is an unfactorable quadratic. And we know that because we got it from imaginary roots. All right. Unfortunately, we're not done yet, though. Okay. So this we know that this polynomial is a factor of f. So what do we do with that now? Okay. Well, we have to divide. I can divide into this to find the remaining factors. All right. So just give me a second. Now, we do have to use long division. All right. It is not a linear term, unfortunately. It is a quadratic polynomial. So we have to use our long division. I'm going to do it fairly quickly just because we're running out of time. All right, so we have x to the fourth minus 2x squared plus 10x. This is third plus 10x squared. Negative 3 plus 2 is negative x cubed. 6x squared minus 10x is negative 4x squared. Okay, now I want this x squared to look like a negative x to the third, so that's going to be a negative x there. Negative 4 minus 2 is negative 6. 2 plus 10 is 12. Minus 60. Now, because this is a factor, we shouldn't have a remainder. So to get the x squared to look like negative 6x, we just need a negative 6. Negative 6x plus 12. Oops, I forgot the x there. X minus 60. Oh, look at that. We get a remainder of 0. So I have my polynomial is equal to x squared minus 2x plus 10. All right, this had our imaginary solutions. Now this side, this is going to have the real solutions. And this we can do pretty much in our heads, right? Two numbers that multiply to 6 are 3 and 2. This is negative, so one of them has to be negative, one of them has to be positive. This is negative, so we're going to do negative 3 plus 2. All right, so there we have our 4 solutions, right? It was a raised to the 4th power, so that means we have 4 zeros. We have 2 real zeros, okay, 2 real solutions at x equals 3 and x equals negative 2. And we have 2 imaginary solutions at x equals 1 plus the square root of 3 and x equals 1 minus the square root of 3. All right, so with the last minute, real quick, I just want to look at the graph of this. No, I did something wrong. 1 second. So we have x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. All right, so here's our graph. We got to zoom all the way out. Well, it's pretty big. It looks like it's only a parabola. Okay. And if we zoom in on the x-axis, oh, well, it only crosses twice. And where does it cross? At negative 2 and 3. All right, so those were the real solutions that we've found. All right, negative 2 and 3. And then those other solutions are imaginary because they never cross the x-axis at 1 plus 3i and 1 minus 3i. All right, any questions? Okay, so we're going to practice this a little tomorrow. Tonight, you're going to have one homework problem, and it's going to be, I want you to try to distribute something like this. So I'm going to give you one solution. You have to find me the other solution, and then find me the polynomial that comes from it. Okay, so tonight I'm not going to ask you to do this whole thing yet. I'm going to go over another example tomorrow when we have more time. All right, but I do want you to try this part. All right, guys, that is all.